this is my ABAQUS 6.14.1 environment. So today I'm going to show you how to build the model. So this is a metal forming, and we have a platen. This is a plate. This is a rigid plate is going to compress. This is raw material. This is raw material. The raw material is called the steel blank. This is I'm going to show you guys how to do that for the parts here. So this is a part and a part 1 and a 2D planar and then deformable and use a shell. The size for this time we use the length, we will use meter, and the stress we will use Pascal. So here, because the plate is the plate. This is a long plate. The long plate. The platen. The platen is we use 0.8, and the steel blank. The raw material is 0.3 multiplied by 0.2. Because of this, and we can just specify approximate size. We use 2 meter. 2 meter will be good enough. And then we press continue. And now we can build. This is the blank. This is a blank. Still blank. So we use a rectangular shape. And then we just specify the dimension. So here is 0.3, and the height is a 0.2, and then we finish, and we're done. So this is the steel blank. And then we build another one. Another one is which is analytical rigid, where the 2 meter will be good enough. And this is the analytical rigid body. So this is continue here, and we just draw a line from here to here. Draw a horizontal line, and then we just press ESC. Okay. Then we dimension it. I told you guys this will be 0.8. So this is my analytical rigid body. This is the platen. It's going to compress. This is steel blank. Done. So this one. Then I can specify because this is a rigid body. I can specify the reference point. I use this reference point. Why is this reference point? Reference point is for this is rigid body. Okay, so rigid body, because we say rigid, that means it is it has infinite stiffness. So Young's modulus is infinitely high in this case. So this guy will not deform, and theoretically, this is just idealized case. Okay, so it's very, very rigid. And so for all these rigid body, and we can just select one reference point, and we apply the boundary conditions just on this reference point, and to stand for the boundary conditions that we apply on this whole rigid body. So this is called reference point. And then we save this one. I will just save this metal forming. Spring 2021. Now I have finished my two parts. And then material. A material steel, we call this a steel. Material behavior, we have, I told you guys, elastic. Press this one, elasticity. Elasticity, we specify the Young's modulus. I told you guys, for this case, the length we use meter, and the pressure, the Young's modulus we use Pascal. So as a result, and here we use 200 gigapascal, and giga means E multiplied by 9, right? So 200 E9, and Poisson's ratio is 0.3. So this is for elastic plus property. And for plasticity, we just use the plasticity, because when we do the metal forming, and this is the raw material, and we'll experience this is plastic deformation. Yield stress, I told you, yield stress, initial yield stress, we use 0.4 gigapascal. This is equals 0.4 gigapascal E9. So this one corresponds to the plastic strain 0. Plastic strain, that's its initial yield strength. At that point, plastic strain is 0, but that is yield strength. So then enter second row, and 0.8 gigapascal, 0.8 E9, 0.8 E9. This corresponds to 1.0. This is, remember, so this is the plastic strain. They are the true strain. ABAQUS uses true strain for this plastic strain here. Now we have finished specifying this is material behavior, material properties. The next step is sections. The section, the solid, homogeneous, we call it steel, or just call section 1 continue, because we only have defined one steel material property, steel, and we can only select this one. See, you can see this is the only option we have. Press OK. Now, up to get these sections here, created a section, and you need to go back to this is the steel blank, and to specify the section. So here, select the region to be assigned a section. Done. You can just click this off. Which section? Because we only have one section, section 1. Here, see, after we specify the section, and so this guy becomes green. And then remember, the rigid body, you cannot size section because we just assume it is rigid. Next step is assembly, and we create distance. First one, we create a plateau. We use the independent, okay? So independent, press OK. And you can select either way, it will be okay. You can talk off and on later, but I will just use independent one here and press OK. So here is our, this is a steel blank, this is a raw material. And then we need to create another instance based on the part 2. And so here, also independent, and press OK here, right? And you can see here, this one is the steel blank, and this one is flattened. And so we have created 2 instances. two instances. Now, we need to assemble them together. And how to assemble them together means that we need to put them in the correct position, relative position between them. Now we can do that. So because we want to compress, this is platen to compress the steel blank from the top surface, on the top surface. So we need to translate this is steel platen from this original position to the top position of this tool. This is a steel blank, I'm sorry. Now we can do it this way, okay? So instance here, translate to, and see, select the edges of the movable instance. I want to select this one. Now this one is highlighted, then done. And select the edge of the fixed instance. Done. Now, select a start point for the direction of contact. Okay, let me try to do it this way. Okay. Translate. Select the instance to be translated here. Now, select a start point for the translation vector. We start here, okay? The center of this platen. We want here to move to this place. And so then select the end point for the translation vector from here. Now, see, you can, this is platen is translated from its original position to this current position. Now we assemble these two instances, and remember to save. Next question, because these two guys, we need to step. Oh. What was wrong? Let me redo it. I did not do something wrong. Instances, translate this one, done. From this point to this point, it's here. Okay, position of instance. Okay. Okay, no, it's okay now. Click this. The steps. And we use static general. Continue. So make sure this nonlinear geometric nonlinearity in geometry is clicked on. And we press OK. Now, because these two instances and they are in contact with each other, so we need to specify the interaction. Because these two guys are going to interact with each other. This is a contact. First, we need to define interaction properties. Double click this one. And interaction properties, we have contact. We just use, this is the name, interaction property 1, continue. And because it's a mechanical only, and there's a tangential behavior. We use penalty, right? And we use penalty, and friction coefficient, we use 0.3. And then, okay, so this is a tangential behavior. And then normal behavior. And normal behavior, we use hard contact and default. And then we'll double check here this one. Yeah, okay, we created, this is interaction property. Now we go back to interactions to establish the interaction between these two instances. interaction. What is the interaction? This is surface to surface. And you need to click this one and see when you create the contact between two surfaces. So you need to select the master surface and the slave surface. The master surface, usually we select this hard material, harder surface as a master surface. For our case, we select this is pattern. This is bottom face. So this is rigid body has two faces. One is top face, one is bottom face. The bottom face of this pattern as a master surface. Right. So how to select this one? Because these two guys are interact each other graphically, and so we need to remove this one. I'm going to show you how to do that. Okay, here, remove using this one. Remove, say, select entities, remove distance, and I select this one. I click OK, done. So now that one is just temporarily invisible, so I can operate on this surface. I'm done now. Then I click this one. See, still select the master surface. Okay, select the master surface. I select this one, and done. See, and because the system detects that this guy has two surfaces. One is the top, and one is the bottom. So the top is magenta. The bottom is yellow. We select the yellow one. Then choose the slave type. Slave type is be very careful. Now we need to put this is a still blank back, and then we click this one, replace all. Now this guy is back. Now this is back, and then I want to remove this pattern in order to select the top surface of this is still blank. Okay, I need to use this one again. Remove that one. I select this one. I remove that one. So choose the slave type. So surface. Select the region. I have needed to press this one. And then don't forget to click this one. Why? Because when this is a pattern compresses, this is still blank. So this left edge might be in contact with the this is a plate. This is the pattern. So that's the reason I select both the top surface and this right surface as a slave surface. And here is not. Here is because here it will not. I'm going to constrain this side and this side, and then press done. Now we have master surface and slave surface, and then you can select the interaction property. And because we only have one, only this guy appears here, and we click OK now. Now you can see that this top surface and the red surface, they are highlighted, and they have some these small squares on them. So that means they are selected. Okay, then we can click this one, replace all. Now, this one and these three edges, this edge, bottom surface, and this top surface, and of this still blank, and so this red surface of still blank, they are selected. Now, save. And then we apply boundary conditions. The boundary conditions. So we use displacement, rotation, and continue. Select the region for the boundary condition, and for this is a bottom surface. We click OK, done. And U1 in the y direction, and it can move, but U2 and UR32 I can adjust and fix. Right? And then another boundary, So on this is the left edge, and also use displacement and rotation. Continue. Click it, and done. Now this time, and the U2 and U1 equals 0. Is U1 equals 0 because well, I will fix it in y direction. And U2, U2 can move in U2, can rotate in U3, and then I click OK. Now you can see this corner node is fixed in both X and Y direction. Save. Another one is that I'm going to compress. This is a pattern. And select this reference point, fine, and then U1 equals 0, and UR3 equals 0, and UR2 I specify is a negative 0.02. I'm going to compress this is the pattern downwards by 0.02 meter. This is very high meter. Okay, remember this is unit is meter. Continue. Now, and then after you finish this one, right click this one, manager, and make sure. So this boundary 1 is from left, boundary 2 is from left, and the boundary 3 can be from step 1. So because boundary 1, boundary 2 are from the initial step. Then click use this one. Then anything else we have not done? Meshing. Let's go here, mesh, and this is a seeded part distance, and select the part distance to be assigned to global seeds, and we use this value. This value will be okay. This value is high, right? We use 0.03. Okay, so this is done, and then select the region, assign the mesh control. We use quadratic, structure. We use done, and then we assign this one. Select this one, done. We select the plane stress. Okay. Now we have finished everything. Then no, I'm sorry. They mesh it. Mesh. Done. Oh, this is a very fine mesh. You can at the very beginning you can use a quarter mesh. Now I have finished everything, and then I can create a job. Level 1. I can continue, and then I can submit it. And you can monitor the progress of the simulation. Monitor. Because this time plasticity is involved, so it might take a longer time. That's okay. Okay, completed. Okay, right click this one, click results. So here is my, I click this one, see? I can see animation, go here, stop, go here, very end, and you can select these results and see the different variable. The stretch components, plastic string components. You can see plastic string components, plastic string components, plastic string components. 2 means YY. And you can see the reaction force. Reaction force 2. Probe, query, node. See? You can just select this node and put your mouse on the reference point of this is a pattern, and you can see RF2. RF2 is very, very huge. Remember, that is Newton. Yeah, this is pretty much what I have. I hope you guys enjoy this video and find this video to be helpful. Also, you need to do the convergence test, and you just use the reaction force on this is still on this pattern as an indicator for the convergence test, as you did for the homework 1. I really hope you guys enjoy this video and find it helpful. If you have any questions, feel free to